Okay, so at the end of the last video, we introduced the different types of radiation. Okay, there were three specific types that we discussed. Okay, the first type of radiation was the alpha radiation. And we said that alpha radiation was composed primarily of just helium nuclei. Okay, where we have a mass number of 4 and an atomic number of 2. So that's 2 protons and 2 neutrons. And it turns out alpha radiation is fairly reactive. In other words, it doesn't travel very far before it actually hits something and reacts with it. Okay, beta radiation, we said, was essentially just a high energy electron. Now the way that we symbolize that is with the Greek letter beta, and then for the atomic number we use a -1, and then the mass number is 0. Okay, and it turns out that beta radiation is far less reactive. Okay, and the thing that the alpha radiation and the beta radiation have in common is that they are both particles. So that sets them apart from gamma radiation, which is actually just energy, okay, just light. Okay, but it's very high energy light. And the way that we symbolize this is with the Greek letter lambda, with an atomic number of 0 and a mass number of 0, because we know light doesn't have any charge or any mass. And the gamma radiation is fairly reactive. Okay, but kind of in a different way than the alpha radiation is. These reactivities have a very strong impact on how much the radiation is capable of penetrating through various materials. So if you were to consider having a surface that was made of, say, lead. Okay, and then on the other side here we have air, and on the right side we have more lead. Now let's say we were to also put on top of that maybe some paper. Okay, and then we have all this air to the left of the paper there. Now, if we were to take radioactive material and suppose that that material was capable of emitting alpha, beta, and gamma radiation, what we would find is that some of the radiation wouldn't even be able to get past this layer of air before it gets either deflected or it gets consumed in some way. Some of the radiation would make its way all the way out to the paper, okay, and once it hits the paper it would not be able to penetrate through the paper. And then another part of the radiation would make its way clear through the air, through the paper, and hit the lead before it gets stopped. Okay. The one that reacts the fastest is going to react with the air. So that's the alpha radiation. Okay. The beta radiation can be stopped by something as simple as a sheet of paper. But the gamma radiation, okay, that's going to require a wall of lead to stop it. Okay, so what we say is that gamma radiation has the greatest penetrating power. Okay, whereas alpha radiation would have the least penetrating power. Okay, and then the beta radiation will be somewhere in the middle there. Okay, so those are your three types of radiation. Those are the atomic symbols that actually describe that type of radiation. And we've been able to now rank those three types of radiation based upon their penetrating power, with alpha radiation having the least penetrating power, gamma having the most, and beta being intermediate.